Unit 2 Chemistry, Chapter 12, Properties of Water. So this whole area of study is about water and the reactions that happen in it and how we can analyse some of those reactions and the things that are dissolved in it. So we'll look at water first of all. Now we should remember that it is a bent or V-shaped molecule which has got covalent bonds within it. So it's covalent molecular. Of course, it's got 2 hydrogens and 1 oxygen. And because the oxygen is much more electronegative than the hydrogen, these are polar bonds. And because it is also asymmetrical, it's got an overall positive end at the hydrogens and an overall negative end. So it is what we call polar, or has a dipole moment, if you want to put it that way. Its physical properties: melts at 0, boils at 100. Hopefully you know that. Has a high surface tension and a high heat of vaporization and fusion. So heat of vaporization and fusion is how much energy it takes to turn it into a gas or turn it into a solid, respectively. Also has a high specific heat capacity. That's the amount of energy it takes to change it by 1 degree. Okay? And as a liquid, it has density of around about 1 gram per mil. So 1 mil of water has a mass of 1 gram. It of course contains hydrogen bonds. So between the slightly negative oxygen of one and the slightly positive hydrogen of another, we can make a hydrogen bond. Each water molecule can make up to 4 different hydrogen bonds. Okay? And it will assume that structure with 4 hydrogen bonds for each of them in its solid form, so when it's ice. Because of these hydrogen bonds, it has a very high melting and boiling point compared to what those of a similar size. It also has a very large liquid range. Okay, so I think we looked at this before when we looked at intermolecular forces, but we would expect that water would have a boiling point of around about -80, -85. Of course, it actually has a boiling point of +100, and that's due to the strength of those hydrogen bonds. Okay. Those hydrogen bonds hold one water molecule close to the other, and remember, when we're turning it from a liquid into a gas, that's what we're breaking. So we need more energy to break the bonds because they are stronger. And because we need more energy, that translates to a higher temperature.